There we are. Fun. And share my screen. All right. All right. Hello and welcome. My name is Brother Stevik or Don or Hey You or Yo Buddy. Um, I answer pretty much anything. I'm very informal, as informal as they allow me to be here. I'm here to teach you the wonderful world of databases. I have been a database administrator since 2001. I've worked in MySQL, SQL, Oracle, Postgres, Mongo. I've done some Hadoop. I've done a couple things. Um, I currently work my day job. I work for a company called Leidos, where I'm the manager of the database team there. Um, and anything else you want to know about me? Feel free to ask. Uh, my biggest accomplishment to date is I've read the complete Cosmere works of Sanderson in 2 years. That was a long haul, but good books if anyone hasn't read them. So tonight we're going to talk about the class ITM 220, the expectations for this semester, how it works. Now, this is going to be a fun semester because we just finished redesigning the entire class. So a lot of things are different. We fixed last couple semesters. All the quizzes were messed up, and we'd have to mess around with the questions, but everything's been fixed. The writing assignments are completely different now. So it's going to be a lot of fun. I think it's going to be a good deal. So before we begin, does anyone have any questions about databases in general? Any questions about what to expect from the class? Anything that you want to learn in the class or looking forward to learning? All right, that's fair. Okay, so first we're going to go over what a common week, what a week in this course looks like, what you're going to be expected to do. Uh, then we'll talk about how the course ends, what the final looks like, and then we'll talk a little bit some code. We'll start talking about some code in here. Okay. So every week there are going to be four. Here. All right. Every week there'll be four basic assignments for you in this class. There'll be a preparation and reading. There'll be exercises. There'll be a quiz, and there'll be a paper. Okay. The exercise and reading is what you'll see here. It'll tell you here's what we're going to learn this week. Here's what chapters in the book to read. Here are the PowerPoint slides that go with those chapters. Here are some links that go with that information and a bunch of other things. There'll be a short quiz that goes with it. Just, I think they're basically like, did you read? Did you really read? Do you promise that you read? And then ask some other questions. A number of you emailed me that there's a problem getting to the book. I put an announcement there just a few minutes ago with the link to get to the book. So that shouldn't be a problem anymore, hopefully, crossing fingers. However, my stance on the book is this. It's a nice book. It's not a fun book. It's not a fiction book. It is not the kind of book that you want to sit down and read and enjoy yourself. So I always suggest using the book as a reference to look stuff up. So you go in there and you need to learn how command works. Go and search in the book, find the command, read that 1 page or 2 pages, and leave it at that. Unless you're into books like that, then more power to you. These links that are here, getting started with MySQL, installing MySQL, every week has these links. And in some cases, they are, I don't want to say they're more important than the book, but they're more informative than the book because these sites that are on are generally updated fairly quickly, fairly consistently, as opposed to books that are one and done. Um, so yeah, so there's that. So look at the links, follow them, read this stuff because the quiz that you will have over here, the questions can come from anything in the book or on these links. If you just download these PowerPoint slides and go through them, it's as good as reading the book because what's what I'm looking for? It summarizes it for you fairly well. Fairly well. Okay. Next one, the exercises. The exercises are the exercises ask you to write code based on what you did that week. So let's look at the ones here for this week, for week 1. Okay, so these are just true false questions for this week. After week 3, you'll start being asked like, here's a scenario, write the code for this scenario. Okay. This one's just making sure you got the installed. Every week we'll have a quiz. You get 2 to 3 attempts on the quiz. The quiz is open books, open notes, open internet, ask ChatGPT, whatever you need to do to find the answers. They realize this is an online course and you can use all of the answers at your disposal. The quizzes are just making sure you understand the commands and everything. There's nothing, it's okay to look up things. I've been in this business for a long time, and you don't always know the answer to the question, but if you know where to find the answer to the question, you're ahead of the game. Everyone can hear me, right? Okay. Should have asked that a few minutes ago until of course, my spiel. Yeah, so these quizzes, there's one every week. They come from a bucket of like 30 or 40 questions. They've all been redone. If there's a question there that doesn't make sense or you feel is wrong or there's a problem with it, please let me know right away so I can take a look at it, either fix it and give you the credit or do whatever. But these are no big deal. The paper. Now, last semester, the paper was just like, you work for a company and you've learned how to use select commands. Please explain how a select command works. This semester, we've changed it to where you're actually building a database throughout the course of the
Someone was detected at
the
your front
semester.
door.
It's called Awesome Pet Services. Every week, you'll be either writing code against the tables or changing the tables or altering the tables. So it's all going to be a cohesive project going across the semester. You'll be asked to write something in code, and then why did you do it that way? So it's going to be interesting. It's going to be fun. It's definitely a different case. In this case, you're going to be asked the code. If you go here, you download the code to create the database. You need to create it in with the CLI, then delete it, and then create it using Workbench. Don't delete that time, and then just write a quick reflection on it. And that's basically what the weekly writing assignments look like. Any questions on anything so far? Everyone keeping up? Not difficult, right? I like to make this class fun. I was the one who designed the writing assignments this week because the other ones were incredibly boring and I was bored grading them. And I don't want to be bored. I want to have fun. And building databases is fun for me. I enjoy it. I've been doing it for a long time. I'll say this a couple times. Like I remember the first time I taught a database design class, it was in the classroom had dry erase balls. It was dry. It was one board. The walls were erased, and I would just design the database starting in one corner and walking all around. And by the time we're done, all the walls had tables and stuff in it, and it was a lot of fun. So I want to impart that fun to you. So we've done the writing assignments this way. So you'll be actually designing and building a database with skins. So that's the week-to-week assignment. The only difference is next week in week 2, who here is familiar with something called Proctorio? Who here absolutely hates Proctorio? It's an evil piece of software designed by evil men. I'm reasonably sure they're all going to outer darkness for building this thing. I can't be sure, but I've got my fingers crossed. Anyway, we don't have to use Proctorio in this class as long as you guys do week 2 the way I asked you to. Week 2, you'll have an assignment to do, but instead of writing it down, I need a 2 to 3 minute video from you guys explaining what you did. So instead of writing a paper that week, you're going to submit a video to me on that. That way we never have to use Proctorio. Okay. I think it was like week 6, 9, and 12 that it said use Proctorio. If you see that, if we didn't take that out yet, don't do it. Don't try. Just do the video next week. Um, okay, so that's the only difference in the week to week stuff. Any questions on the week to week stuff? All right, silence is consent. End of semester. Because we have to have a capstone event every semester, there are one of two things you can do. The first choice is a final project, and we're going to talk about that in week 3. You can go look at it if you want. But the final project is you design and build a database for an application of your creation and make the tables, make the constraints, make the queries, make everything, and then explain to me how you did and why. It is it's a lot of fun and a lot of people come up with like really great ideas. Last semester, someone did a database to record roller coasters across the country. One student from 5 or 6 semesters ago built a. This one was really cool. This was a hard one. Built a database that not only recorded food storage but also compared it to recipes to tell you what you could make out of your food storage. So you can do a lot of fun things with this. I really highly recommend doing the final project. So what happens is in the final project, starting in week 3, there's explanation. We'll talk about, like I said, explaining how to do it, and you'll just start designing it, work. Yeah, you'll meet up. We'll talk about it on Tuesday nights about the design process, how it's going. Ask questions. You can talk to me one on one. The big difference in the final project, if you're doing it, is your weekly writing assignments, your papers, aren't doing the Possum database service unless you want to. They're just a kind of like a journal to me on how you're doing. So, like, it's week 4, Pro Civic, I came up with my topic. Here's what it's going to be. Blah, 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 blah. Here's what I'm thinking of doing. What do you think? And, we'll have a back and forth through your papers on how to do that. But that's the only real difference between the final project. If you opt not to do the final project, we of course have a required final exam. It's open book, open note, open internet, open friend, open whatever. Because it's the same questions from the quiz. So whichever one you do is great. Like I said, the final projects are way more fun than the final exam. But it's up to you because it's free agency, right? Any questions on that? All right. So that's the course in a nutshell. It's like I said, it's not incredibly difficult. There is a lot of learning. There's some curves in there. So starting this week, you're gonna start writing some. You're gonna be given code to run yourself. Starting next week, you're gonna be asked to write code. On the Tuesday meetings, I will go over the code that you need to write and show you how to do it, and you'll have to, transpose that into what you're asked to do for the assignments that are going from that point on. Um, and my lectures on Tuesday nights will probably by week 7, I will have given you everything you know in code. I will cover all the code that you need to know by 7. So 8, 9, 10, 11, 12, and 13, you're going to be kind of, I'll still be here meeting with you guys, but you'll have all the tools you need to finish those assignments by 7. It might be 8 this year because I've changed some of the assignments toward the end on the way to be done. So we'll see where it goes. Um, but yeah, that's it. Are there any questions on any of the assignments? Because I'm going to start talking about code and the history of SQL. All right, here comes the real stuff, man.
I've got a question.
Hey,
So, I was trying to do this week's assignments, but I couldn't find any option to download the program We Need SQL on Mac.
Okay, I will send you the instructions. Yeah, there's a actually here's who here uses. It's okay. We're all friends here, right? Who here uses like AI, like ChatGPT, Copilot, Gemini, any of those? It's okay to say yes because I do all the time, every day. I'm in that stuff. Okay. Lewis, if you go in there and say, how do I install MySQL on Mac OS, it'll just give you the instructions because that's what I sent out. So I'll send you what I got, but if you just do that, it'll give you the answers. Okay. Um, anyway, so by the way, we have software that checks if you're using AI to write your assignments. You really can't with these writing assignments because you got to write code that goes with it. Um, but AI is a great tool. I use it to clean up my language in the stuff I have to write. So feel free to do that. We do have software that checks to see if it's AI. It's not incredibly accurate, so I don't really go by it. But um, BYU is really kind of embracing AI. I think the one of these semesters coming up, there won't be a textbook anymore. It'll just be an AI engine that you can access, which is kind of cool. All right. So let me get this here. All right. And let me get a new great tab here. Okay. So who can, what is a database? Anyone want to field that question? That big freakish question. What is a database? Database is any document that holds data. That would be a spreadsheet, a Word document, a PDF file. Anything that holds that data is considered a database of sorts. Excel is a great example, or your spreadsheets are a great example. Those are technically databases because they hold data in columns and in rows that people use to reference and find stuff with. I love a great spreadsheet. I think they're fun to play with. Um, I make them for fun sometimes. It's true. I play a game called Star Wars Galaxy of Heroes. I've got spreadsheets for the game because I can. But the thing about those databases is they're not what we term relational databases because it's just one giant table. If you pull up Excel, you start with column A and you go to column triple A, triple Z, triple whatever, and row 60 jillion, but it's just one giant table and it doesn't relate to anything. When you're talking about your database engines like Microsoft SQL Server, MySQL, Oracle, Mongo, you have something called a relational database. Okay. A relational database is when you have a series of tables that are linked together by constraints that all share the data. Let me show you what that looks like. Uh, here. So this is a relational database. I've got one, two, three, four, five, six. I get 7 tables. Each holds information that, as a collective, makes sense, but individually it doesn't. Like I've got a table on spacecraft. This is what I did, a database that I played with one time for NASA. A destination table, a location launch table, an astronauts table. Individually, they have information, but it doesn't give me the whole picture. But you see all these little connectors, right? So all these tables connect with each other so you can pull all the information out as a whole. When you're designing a database or when a database is created, each table has to be what we refer to as normalized. And that basically means no duplicate data, identify unique row identifiers. Okay, so we'll just go with those two right now. So no duplicate data, which means nothing happens in a table twice, and every row has a unique identifier on that row, be it a number or whatever it's going to be. When you normalize your data, it flows easier through all the other tables out to the world so they can see it. So when I look here at this one here, right? This is basically tracking the missions and what the astronaut who the astronauts were on it, right? So I've got a table for the missions. I've got a table for astronauts, and in that table is only information about astronauts. I don't want to know anything other than like their name, their social security number, their phone numbers, just anything that identifies the astronaut themselves. Same thing with spacecraft. All I want to know is stuff that deals with the spacecraft. So, so here I've got a table called missions. I could just have a table and say, okay, I'm going to type in the name of the spacecraft. I'm going to type in where it landed. I'm going to type in where it launched from, all this other stuff. But instead, what I did is I have all these things connecting together. I've got this spacecraft table links to missions. So if it's in here, I can put it in here. I have astronauts connected to missions. So if there's an astronaut, I can tell you, I can get a drop down menu and have these astronauts in that mission. This is going to make a lot more sense in the coming weeks. I'm just kind of setting the stage. If I go too fast or say something that you don't understand, please stop me and I will explain. I love questions, and sometimes they take me off track into like some kind of real deep topic on databases. All right. So that's what a database is. That's how a database works. It's a series of tables that connect together, that share data, and put it into a pristine format where people look at and go, oh, look, that's it. Every website you go to runs on a database of some sort. Okay. Now, how do we make databases happen? So T-SQL is the language that we use for programming in SQL Server. It stands for transactional structured query language. Transactional structured query language. And in there, we've got two basic types of commands. We've got data definition. Data definition language and data manipulation language. So this is DDL and this is DML. Okay. There are three basic commands in DDL. There's create, there's alter, and there's drop. In DML, there's four basic commands. There's select, insert, update, and delete. I'm going to get into these commands next week. I'm going to talk about these three today. So data definition language are the commands that we use to create databases and create the objects that hold, manipulate, and move data and house the data. And the thing I love about anyone here like ever deal with like C# or C++ or Java or Java Sharp or any program languages? No? You have? Okay, a little bit. They're not English. They're weird commands and hash marks and stuff like that. T-SQL is English. Create database. That's fairly simple. Drop database. Um, so create something, alter, changes it, and drop gets rid of it. And when you get rid of it, there's no bringing it back. It's a one-shot deal. So let's look at this code I've got over here. Where's the code that I have? Where'd my code go? Oh no, there. Did I?
Someone was detected at your front door.
Oh, okay. We're going to break our new rule. We're not going to. Okay. Okay. So I've got a command here, create table demo. I run that. I look over here. I refresh. And there's the database demo. There's nothing in it. Completely empty. Before you can do anything, you've got to put a use command, what database you're going to use. For your exercises um, in your exercises, you're in a database called Sakilla. For your writing assignments, you're in a database called Positive, I think it's Awesome Pets. And if you make your own, you'll do whatever you call yourself. So you go use demo, and I'm using that. It says that's it. It's highlighted over here now. I've got a create table statement here. I'm going to create table demo. And each of these is a different column that I'm create in the database. The first one is TDID. The format in doing this is the name of the column, the data type, any special commands, and then this is for the first column called primary key. So here, the name of the column is TDID. The data type is int, which means integer, which means any number between negative 16 million and positive 16 million, thereabouts. Auto increment means if you don't put a number in there, it'll just take the next number that it has. So if the last number was 16, it'll go to 17. Primary key means that this is the most important column in the table because it's how it's indexed. That's the default index column. I've got last name, varchar that means variable character, which means, so what this means is you can put characters into this up to 100 characters. So you can do 0 to 100. If you try 101, you're going to get an error. So 100 characters, right? Not null means you must have an entry in it. So as we're doing this, you're seeing that, oh, by the way, primary key basically means not null and unique. So it can never duplicate and it can't ever be blank. So as we're building the table, we're giving rules on what can and can't be done in this table. First name, varchar 100, not null. Phone number, varchar 15. Put null here. And because I got to get fancy once in a while, this is like, easy stuff. This is like way advanced. This is just to show you. I will talk about advanced stuff even in these early lectures, just so you see the power of what's there. And look, weeks down, you'll be able to do the same thing. So these are the first 4 columns: TDID, last name, first name, and then phone number. Okay. This is what we refer to as a check constraint. Constraints are any rules you put on the columns or the database or the tables that have to be followed, or it won't be accessible to put the data into it. Does that make sense? Okay. So here I've got phone number varchar 15, which means you have at most 15 characters in there. It's allowed to be null, but I've got a check constraint on that column, right? So what reg exp means, it stands for regular expression. So basically what this is saying is that whatever goes into this column must be formatted like a phone number. It's going to have starting parenthesis. You can have 3 characters, 1 through 9. And then here, it can have 3 characters, 1 through 9. It has to have the dash. And it can have 4 characters, 0 through 9. And then the dollars. That dollar sign just means it's over. That's a little advanced, but do you kind of see what that's trying to do? Does that make sense? So we delve into this world of creation of databases and creating things, we can make sure that the data that goes into these columns is exactly what we want. Because if you want to mess up a database and get bad data in a database, the number one thing you do is let people put data in it. It's like having kids and a kitchen. Your kids are guaranteed to mess up your kitchen and not clean it up. That's what kids are for, at least to the age of 22 or 23. Um, if we create a database and we allow people to put data in it and we don't have rules around that, they're going to put bad data in our database. And we cannot allow that. So there are many ways that we can make sure that only good data goes in, and this is one of them. We can say anything that goes in here must meet this criteria. Okay. So let me go ahead and create a database. I'm going to use the demo database, and I'm going to go ahead and create this table. And over here, it says it got created. I go over into I refresh this over here. I refresh this over here. And now my table is here. But I forgot to put email in because we all have email addresses now, right? So I have another command, alter table demo, and then add, and just the column I want to add. Here it's the email column, it's varchar 100, and it can be null. I run that. I look here in my columns. It's there. It wasn't there before. It's there now. I don't want this table anymore. I hit drop table. And that table is gone. I don't want the database anymore. I hit drop database. And the database is gone. You see what I mean by when I say that this is a fairly simple thing to do? On the surface, this is not difficult. It can get difficult. This is fancy and tricky. But this stuff, it just makes does it just make sense, y'all? How this kind of works out? Okay. So this week's lesson, so you're gonna let me show you the code you're looking at here. Uh, so this is the data you're gonna be working with today for your assignment. Let's just walk through this real quick because you're just gonna run this. This isn't something that you're gonna like figure out. We just gave this to you. Okay. So here we're creating a database called Possum Pets. We're going to use that database. We're going to create a table called clients. We're going to create a table called pets. And you see, so we're going to talk about foreign keys in a second, right? And then we got a table called appointments. So looking at this, does this make sense to you guys? With the examination of the foreign key question? Like, this is a client ID. It's going to be an integer. Pet's name is going to be a varchar 50. Species is a varchar 50. Breed is a varchar 50. It's all text. Weight is decimal, 5-2. 5 before and 2 after the decimal point. Age is an int. We're not going to talk about it today, but I got about a 25-minute discussion on data types because they're very, very interesting. Remember I said, so kind of a preview of this. I said that an integer, this command here is 16 million to negative 16 million. Last time I checked, dogs don't live that long. So this column here, this data type here is too big for age. There are other data types that are smaller and more succinct. We'll get into that. We'll get more into that later. But this is because we're gonna play with this later on, right? But yeah, so that's what this is. So what this foreign key thing is, let me do this. This one here. So here, splitting. Oh wait, no. I'll go here. Ooh. I haven't done this. Oh, reverse engineer. I do that. Okay. Okay, so what I just did was magic. What I just did was called I reverse engineered the database. So this thing here, I should have told you before, this is called an ERD. It is an entity relationship diagram. It is a visual representation of the database. Okay. Um, these lines here are foreign keys. So when you saw this command here, foreign key, that's what this means. So basically what a foreign key is, so you see that here I've got client ID and here I've got client ID. Here I've got appointments and here I've got appointment is over here with head ID over here, right? So what that means is the value of this column has to be in here. Remember I said that we don't want people messing up our data, right? So if I had a form on my computer and I had an intake person at my grooming clinic, my grooming salon, and they could type in the name of the client, and that name was like, Rabinowitz, the odds of them spelling that name correctly are very low, unless their name is Rabinowitz. So if you can imagine in your head, there's an application for inputting people into this application, and there's a drop down, and then they find Rabinowitz, right? So what I'm going to do is Rabinowitz exists in the client table. I'm going to take the client ID and put it in the pets table. That way I know Rabinowitz owns that dog or that cat or that animal. And then over here on the appointments, I need to know what pet is involved in this appointment. So here, the pet ID exists over here. They're the same pet ID, right? So what this means is with a foreign key, if this value doesn't exist here, it can't exist here. And this is for data cleanliness. So we can't have people type in random names in the appointment table, random dog names in the appointment table that don't exist in the actual pets table. So they have to exist. So this is another way to keep data clean. So we can connect tables using foreign keys to which anyone will put and it'll show you the two lines that are connected, right? So with foreign keys, to exist to here, it has to exist here. Does that make sense? Am I going too fast for anybody? I mean, it's 10:11 here in Florida, which is where I am. I'm in Orlando, Florida. Um, so it's getting on like bedtime here. I don't know where it is. Usually everyone else is like on the West Coast, so it's still the sun's probably still up for you guys. All right. So that pretty much puts me where I wanted to be tonight. Um, for this week, your work is to do the icebreaker, to install MySQL, to run this code. There's some insert statements down here. To run these insert statements in the CLI, and then to run it in Workbench. And make sure you keep one of them. And then tell me which one you like better, basically. I won't tell you which one I like better because I don't want to color your judgment, but it's not CLI. Um, anyway, all right. Any questions on anything? Everyone good? All right. Well, that's fantastic. Um, if there are no, so this is now in the coming weeks, like starting with week 4 and 5, when we're done with my lecture, we will just design a database together so you guys can get the habit of designing databases. For the longest time in this class, which is called database design and administration or something like that, we never designed databases, but now we are. If there are no questions, so what happens is I've recorded this tonight. I'll post it so anyone who wasn't here, no one ever watches it. If you're not here, you don't watch it. I don't know why I bother, but it's kind of fun to do. I used to do a whole thing where I like put a secret word in the video that you had to watch to find, and then that was a question on the quiz, but that just got to be too much of effort. I gave that up. Um, and then I'll actually the cool thing about Zoom now, I will have an AI transcript of everything we talked about tonight. That'll go there too. And then it's off to the races. If there are no questions, as I say in my other job, I'll give you 16 minutes back to your day. They're supposed to go 10:30, but I'm good with giving you some time back so I can get to bed a little earlier. Because seminary here is 5 o'clock in the morning. So I still got kids that I got to tote there, at least for the next couple weeks until school's out. So thank you for coming tonight. I hope to see you guys through the entire semester. If you need me, you know where to find me. Okay. Have a good night.
Thank you so much.
You.
Bye.
Thank you.
You're welcome.